All right, so I would like to introduce a new equation for you. This is the equation for torque, and torque is equal to force times distance. The units are just the Newton meter, and it's worth noting that this force is perpendicular to the distance, and then of course the unit is the meters. Oops, that's not true at all. The force is the Newton. Wow. Good thing I was reading out loud. The force is the Newton, it's perpendicular. The distance is meters, that's just a unit, and it's perpendicular. Be careful with this. Torque and work are both force times distance. Remember, we had right up here, force times distance. But here, keyword there is parallel. This force and this distance are parallel. And down here for torque, the distance is perpendicular. With work, it has to be moving. And it may or may not be moving when we're dealing with torque. So I have a couple of things to show you here, a couple examples, as soon as I can find them. Here would be an example of what we're talking about. We would have a force of 9.8 newtons downwards. It would be a distance. Notice how this distance and this torque and this force are perpendicular to each other. So it would have a distance of 3. So if we wanted to find the torque that is on this overall teeter-totter, there would be a 98 meter, sorry, I think I said 9.8 a second ago, 98 newtons times 3, and then that would give you that torque. In this case, since it's making this thing twist this direction, that would be a clockwise torque. Torque is described in directions, typically clockwise versus counterclockwise. If we were to let this go, this thing would start rotating this teeter-totter, this would go down. Another scenario that I have here would be something that would look like this. Very similar, only now we have something on both sides. So we have this exact same thing as before, only I added an imaginary, another something. This would be 10 kilograms, which would be 98 newtons down. This one would be 20 kilograms. That would be 196 newtons down. So you notice it's double the mass. And I cut the distance in half, 3 meters to 1.5 meters. And in fact, this would actually balance because the product of this distance, which is perpendicular to the force, and the product of this distance, which is perpendicular to the force, the product of those two would be the same. So in fact, the torque on this overall beam would be the same. So you would have a clockwise torque this direction and a counterclockwise torque this direction, and they would balance out and this would be balanced. But to calculate a torque, all you do is multiply the distance from the pivot point times the force perpendicular. This is very, very different than work. This does not have to be moving. It can be moving, or it does not have to be moving, whereas work has to be moving. Thank you and good luck.